All right, so today you're going to talk about something that's a huge deal for making AI actually useful: memory. We're diving into how AI agents remember things. You can think of it as the secret sauce that turns a kind of clunky tool into a smart assistant. And believe me, it's totally changing how AI products are being built. You know that feeling, right? When you're talking to an AI, and then a second later, it's like it's got total amnesia. It completely forgets everything you just said. It's so frustrating. It's like having to reintroduce yourself to your own assistant every single morning. And that right there is what we can call the forgetful assistant problem. Because at the end of the day, without a good, solid long-term memory, AI agents are just stuck. They can't build on what you've told them. They can't learn from the past. And that just leads to a really bad user experience that feels repetitive and, well, not very smart. This quote really gets to the heart of it. A great assistant, whether it's a person or an AI, remembers things. They build on your past conversations. They know your preferences, your projects. Without that memory, they're just not that helpful. So how do we fix this? Well, the solution, and you might have guessed this, is to design AI agents with memory systems that are, kind of inspired by our own brains. To solve that forgetful assistant problem, engineers have come up with 3 different types of memory that all work together. Let's break them down. And this image right here, this is basically our roadmap for the next few minutes. It shows the 3 core memory types we're about to get into: semantic, episodic, and procedural. Just think of this as the agent's brain, with different parts for different kinds of information. Okay, first up, we've got semantic memory. This is basically the agent's internal encyclopedia. It's all about the what, the hard facts and data it's learned and stored about the world, and more importantly, about you. So what are we talking about here? Well, it could be stuff like your preference for meetings in the morning, or the fact that your coworker Sarah is based in Chicago. It can even learn your specific tone and style so it can draft emails that sound just like you. These are the little details that make an assistant feel like it's your assistant. Okay, so we have the what. Now let's talk about the when and where. And that brings us to our next type: episodic memory. This is the agent's ability to recall entire past experiences or conversations, which gives it a whole library of context to pull from. This is just incredibly powerful, because by storing these past interactions as examples, the agent starts to see patterns. It can look at a new email and go, this looks a lot like that time I scheduled a demo last week. I know what to do here. It gives it guidance. And that brings us to our third and final type: procedural memory. This is the how-to guide. It's the instruction manual for the agent, the learned skills that tell it how to actually do things. You know how you don't have to think about how to ride a bike? That's your procedural memory. For an AI agent, this is where its core instructions are stored. Things like its main system prompt that tells it what its job is, or the step-by-step instructions for how to use a specific tool to book a flight. Okay, so we've got these 3 powerful memory types all working together. That's great. But, a memory isn't much good if it can't be updated, right? So how does an agent actually learn new things and add them to its memory? Well, there are basically 2 main ways developers handle this. So you've got 2 main ways to do this. The first is what's called the hot path. This is where the agent updates its memory in real time, right in the middle of talking to you. The other way is a background process, which is offline. A totally separate system handles the updates later. And yeah, each one has its pros and cons. And what's so interesting here is the trade-off you have to make. If you go with the hot path, things are simpler, the updates are instant, but it can slow down the agent's response. On the other hand, updating in the background keeps the main agent feeling super fast, but now your whole system's more complicated, and there's a delay before the agent actually learns the new thing. Okay, enough theory. Let's see how this all clicks together in a real-world example. We're going to look at an AI agent that does something we could probably all use help with: managing our email inbox. Just look at how perfectly these different memory types play together. First up, triage. The agent uses its episodic memory. It looks at a few past examples to figure out, hey, is this email even important? If the answer is yes, it moves to the plan step. Here, it dips into its semantic memory to pull out facts like your meeting times. And finally, it uses its procedural memory, its core how-to guide, to actually write and send the email. So here's the bottom line. It's not about any single type of memory. It's the way all 3 work together: the facts, the experiences, and the instructions, that turns a basic chatbot into a genuinely helpful personal assistant that actually learns and gets better over time. So as you can see, getting a handle on how AI agents remember is really a cornerstone of building great AI products today. This isn't just some techie detail. It's fundamental to making AI that actually feels intelligent and, useful. And this is not some niche thing we're talking about. All these advanced topics, agentic AI, its architecture, how you even evaluate it, these are at the very center of AI product strategy now. Understanding memory is a must-have for anyone looking to build cool stuff in this space, whether you're an engineer, a designer, or a PM. So, what's next? If you want to go deeper on this and really stay ahead of the curve, I can't recommend the AI Product Management Playbook by Deepak Deo enough. It's an amazing resource for anyone who's serious about building the next generation of AI. Thanks so much for tuning in.